Okay, so let us change tracks a bit. Our focus this week is going to be about studying a class of games which are known as cooperative transferable utility games. So this seems like a mouthful. So let us understand what these sort of games are of. So these are games basically that involve a division of money among players. And the rules of the game are going to allow for making binding agreements, which means that we'll know for sure that these agreements, if they are made, will be honored, right? And we'll see that in order to kind of analyze this sort of games, we need to develop a new notion of solution concept, right? So other examples of solution concept that you have seen before would example be dominant strategy or Nash equilibrium and so on. So in order to analyze this sort of games, those notions are not necessarily the right notion. And so we need new tools, right? So the tool that we'll be focusing on this week is what is known as a Shapley value. So this is basically, you can think of it as a way of dividing the money in a way that a judge or arbitrator is likely to recommend, right? So we'll see more details about how you can kind of like get into that. So the use of the word cooperative would suggest that this is actually a part of what is known as cooperative games, right? So just to remind you, cooperative games are basically games in which players enter into mutually binding agreements, right? So the key word is binding here. So an example of cooperative game would be, for instance, be the economic negotiations that often conclude in a contract which is binding on all parties, right? So here, once the contract has already been signed, players no longer think about like breaking the contract or thinking about whether it's worthwhile for them to stick to the contract, right? So it's binding in that sense. Why not? Probably they have huge penalties attached to breaching such a contract, and that is why they are not doing it. We don't per se care about the reason about why they don't do it. The important thing for us is that they cannot actually break this contract, right? In contrast to this, most of the lectures that we have been kind of like discussing about has focused on non-cooperative games. So what are non-cooperative games? Non-cooperative games are basically games in which players into non-binding agreements. So notice again the differences between binding and non-binding. So here an example would be political agreements like that between countries, right? So these are generally non-binding in the sense that these parties can actually kind of like stick to this agreement only as long as it is suitable for them, right? But then later on, they can potentially get out of the agreement. So one kind of like aspect of any such non-cooperative interaction would be thinking about, okay, should we stick to the agreement or should we kind of like get out of the agreement? What are the costs of benefits of that? So such things would not be of interest to us in doing cooperative games, for example, right? So here, once agreement is made, you are going to stick to it, right? Okay, so how would we mathematically think of such games? So we are going to describe a cooperative game by using these two elements, right? So we have here the word N and V. So what does this mean? So N is basically a set which denotes the different players that are involved in this game. Okay, so if there are N players, we will just write it as 1, 2, 3, comma N. And what is V? So V is something new. So V is what we will call the coalition function, right? So let us unpack this term a bit. So first, what is a coalition in this cooperative game? So every subset of N, remember N is the set of players, is actually called a coalition. Okay. So what is a coalition? Coalition is basically any subset of the set of players. Okay. So when we say that a coalition S was formed, for instance, what we mean is that all the coalition members in this set S, they have given their consent to the formation of the coalition S, right? So for example, here out of this N, if we say that a coalition 1, 2 was formed, that meant that 1 and 2 have given a consent to form a coalition between themselves. Okay. Now, whenever a coalition is going to be formed, there's going to be an amount of money that is going to be generated in this situation, right? So if a coalition S is formed, then an amount of money VS is going to be generated. And this VS is then called the coalition worth of S, right? So this is how this the V component that we had discussed in the description of the game kind of like emerges, right? So these are the two components that are going to come up whenever we describe such a game that we are considering. So let's take some examples to make things a bit more concrete, right? So the first example concerns advertising agent who approaches three individuals, 1, 2, and 3, and asks them if they are interested in signing an advertisement where they will say that they are going to use a particular brand of sports equipment, right? So you can imagine these might be hockey players who might be saying, they use products from this particular company, or it might be cricket players who say that, they use cricket kits from this particular brand and so on, right? Okay. So the agent actually, let's think about what the agent told them. So the agent says that he is interested in obtaining at least two signatures. So if he obtains less than two signatures out of these three, then it is not worth going ahead with the advertisement campaign for him. So if players one and two sign, then the agent is willing to pay them a total of 100 lakhs, right? And if players one and three sign, then the agent is going to pay them a total of 100 lakhs. So note that we are saying a total of 100 lakhs, right? We are not specifying what is going to be the share going to player one and going to be player three, right? So we'll have to later figure out of this 100 lakhs, how much will go to one and how much will go to three. In fact, that's part of like the things that we are interested in solving whenever have some solution concepts that we can apply, right? Okay. And instead, if two and three sign, then the player agent is only willing to pay them a total of 50 lakhs, right? So the total amount that will go to two and three, if only two and three sign, you notice, is less than that. So that can be due to the reason perhaps, one has more recognition among the common public. So if one endorses a particular product, then the company anticipates that there might be greater sale, right? Okay. So the agent was interested in obtaining at least two signatures. What happens if all three agree to sign, right? Then the agent is going to pay them a total of 120 lakhs, right? Because the agent feels that in that case, there is kind of like more money because there may be like a particular um, advertising segment that appeals to this particular player being in the advertisement, right? Okay. So this is the situation. Now, what does the formation of coalition mean in this context? So what it means is basically an agreement of its member to sign up for the advertisement, right? So now let's think about how to kind of like mathematically describe this. So first, remember, we need to kind of like describe two things, right? So this, if you go back to our general definition of the game, we need to discuss what is n, and we need to discuss what is this v, which is the coalition function. So n is pretty clear here. N is this the three players that the agents had interested had approached, right? So n is equal to 1 to 3. And now the different coalitions that can form are the subsets of this set n. And what we need is to kind of like discuss the coalition function, which will basically map any subset of n into a number, right? Okay, so let's think about how it will work here. So notice that if 1 and 2 are in the coalition, which means that 1 and 2 have agreed to sign the advertisement, but only 1 and 2 have signed, then the agent had said that the agent is going to pay them 100 lakhs, right? So that means that the value of this coalition, 1 and 2, is 100. So I'm skipping the lakh because, I just have to keep on writing lakhs. So the unit is lakhs here, right? So the value of the coalition 1 and 2 is 100 lakhs. And so therefore V12 is equal to 100, right? What happens if only 1 and 3 sign up? In that case, again, the same thing. So then the value of the coalition in that case is also 100, right? But if only 2 and 3 sign up, then the agent is only going to pay them a total of 50 lakhs. So therefore the value of coalition, which is formed if only 2 and 3 agree to sign, is 50, right? And similarly, if all three agree to sign, then we know it was 120 lakhs. So therefore, mathematically, we can write this as V of 1 to 3 is 120, right? So this is just kind of like translating what we had there in the language and the mathematical formalism of cooperative games, right? But remember, it's not that we just have to assign kind of like numbers to these coalitions. We have to assign it to all subsets of n, right? So what are the other things that could have happened? You could have had only one agreeing to sign up. So then this is the value of the coalition if only one has agreed to sign up for the advertisement. So in this case, the agent was interested in obtaining at least two signatures. In this case, the agent will not go ahead with that, right? And so therefore V of 1 is equal to 0, right? Same reasoning suggests that V of 2 and V of 3 are equal to 0. And finally, the empty set is also a subset of this n, and therefore we have to also assign a number. So the common convention is to assign a number 0 to the empty set, right? So this is the complete description of the game, right? Again, you specify n, which is the different players that are there, and then you basically specify for each subset of n, what is the value of the coalition? And this complete description of this value of the coalition is what is the coalition function, right? So the function basically will take in as input any subset of n and will give as an output a number, okay? So there's also a way of pictorially describing this game, okay? So let's just take a look because sometimes you might come across this. So we have got these three players, 1, 2, and 3, right? And we have some numbers here, right? So what do these numbers mean? So for example, this 0 indicates that if only 1 is forming a coalition, then the value is 0. This 0 here in the middle indicates that if only 2 is forming a coalition, then the value is again 0. And if only 3 is forming, then the value is 0, right? What happens if 1 and 3 are forming? So that's this arc that you see at the top. And so there the value of the coalition is 100. What happens if 1 and 2 are forming? Then again, it's 100. This is the 100 you see here. And what happens if 2 and 3 are only forming? Then you see the 50, right? And this 120 at the end suggests that what is the value of the coalition if all the three players involved are forming the coalition, right? So we are not going to be using the graphical description so much. I'm just kind of like giving it to you here because, you know, in some case, if you encounter it, you will know how to interpret this, right? Okay. So in terms of the solution concept, one of the questions we might be interested in is that suppose the three kind of like go to a arbitrator or a judge or let's say their manager, and then they ask that, you know, suppose that we all of three are signing up. So what we have said so far is that if all three sign up, you're going to get 120 lakhs in total, but we have not specified out of this 120 lakhs, how much should go to player 1, how much should go to player 2, how much should go to player 3, right? So suppose they take it to their kind of like coach and ask him, okay, how should we kind of like think about how to kind of like divide up this 120 lakhs among the three of us, then what would be kind of like one reasonable answer, right? And we'll expand on what we mean by the word reasonable in later parts of this week's lectures. Okay, let's look at some other games. So a common type of game that is often studied is bargaining game. So I'll give you here two different versions. So one involving two players and then the second one involving generally n players. So the most basic version of this bargaining game is that suppose two people are kind of like bargaining and they cannot come to an agreement, then they are going to get nothing, right? So we are going to kind of say that then each of them is going to get 0 separately. However, if these two players can come to an agreement, right, then they are going to get some surplus, and let's call that surplus 1 here, right? So then the description of the mathematical description of the game would be, again, the two players are 1 and 2. So this is n, and the coalition function would have to specify a value corresponding to each subset of n. So as usual, v of phi is 0. So I'm not stating that here. However, if the players cannot come to an agreement, so that v of 1 is going to be 0 and v of 2 is going to be 0. But if they can come to an agreement, so that we have got v of 1 comma 2, then in that case, that value of that agreement is worth 1, right? So this is how we can describe this the situation that we had mathematically, okay? And graphically, again, you have got 1 and 2. If they are kind of like individually just sticking to themselves, then they get 0 each. However, if they form an agreement between them, then this surplus of 1 is generated. So the pure bargaining game is just a generalization of this. Instead of two players, now suppose you have n players, and an agreement needs to be reached between all these n players in order for some surplus to be generated, right? So even if any one of them say that they don't agree to this agreement, then nothing is generated, right? So this is the situation we have. How would we describe it mathematically? We have got, again, the set of players as 1 to 3 to n. And what's the value of the coalition? So the value of the coalition is equal to 1 only if all the players are in the coalition, right? Only if you have got 1, 2, 3, n in the coalition. But in any other case, the value of the coalition is equal to 0, right? So this is one concise way of representing that. Okay, let's look at some more examples. So here I'm going to first discuss to you verbally what is going on, and then we'll think about how to translate that mathematically, right? So this is a simplest possible version of a buyer-seller game, right? So imagine that you have got two players. Player 1 has a painting that he is willing to sell, of course, for a price, not for free. And player 2 is interested in buying the painting, okay? And when will a deal be made between these two different players? So a deal will only be made if the seller sets a lower worth on the painting than the buyer does, right? And we would expect that a deal would be made only if both the players are kind of profiting from making the deal. Otherwise, why would they make the deal in the first place, right? So let's put some numbers to make it concrete. So imagine that the worth of painting to the seller is 100,000 or 1 lakh, right? So what this means is that if the offer to the seller is for an amount less than 1 lakh, let's say 90,000, then the seller will not accept to sell the painting, right? So the seller will only accept to sell the painting if he gets 1 lakh or above, right? In fact, if he impose this condition that he must strictly be profiting from making this trade, then he needs an amount strictly more than 1 lakh, okay? But would the buyer be interested in kind of like giving this amount of money, right? So that depends on how much is the painting worth to the buyer, right? So in this example, let's imagine that the painting is worth 150,000 to the buyer. So what that means is that the buyer will not pay more than 1.5 lakhs to acquire the painting, right? By the way, if we were to kind of link it to things we had discussed in the previous lectures, you can think of these as reservation prices, right? So the reservation price of the seller is the lowest price for which one is willing to accept the deal, and the reservation price of a buyer is the highest price that the buyer is willing to pay for a good, right? So remember, we had discussed these things before, but we don't need to use those terminology. I hope this is clear. Okay. So what can be an example of a deal? So for example, suppose the painting is sold for 130,000 or 1.3 lakh. In this case, will the seller make a profit? Yes, because the seller was interested in getting at least 1 lakh. So therefore, the seller makes a profit of 30,000. What about the buyer? Well, the buyer was willing to pay at most 1.5 lakh and is ending up paying 1.3 lakh. So therefore, the buyer also ends up making a profit of 20,000, right? But this is just one example of such a deal. You could have had, for example, a deal being made for 110,000 as well, right? In which case the seller would have made a profit of 10,000 and the buyer would have made a profit of 40,000 because that's he's underpaying by 40,000, right? He had remember, a reservation price of 1.5 lakh and he ends up paying only 1.1 lakh, right? Okay. So what does formation of coalition mean in this case? That means basically 1 and 2 agree to kind of like have this transaction carried out, right? So again, mathematically, how do we describe this game? So you have got these two players, the buyer and the seller, right? So basically the player 1, remember, is the seller and player 2 is the buyer, right? So let's think about it. What is the coalition function? The coalition function would have to specify for each subset of n, what's the value. So if you have got only one staying separately, then the value is basically just 1 lakh, right? Because then no trade is taking place. The value of no trade to person 2, who was the buyer, is 0. But if a trade does take place, then the value is actually 150,000, right? Why is it 150,000? Because think of like an exchange of amount of money, let's say 30,000 in the above example. So that's what the seller is getting. What about the buyer? The buyer is getting the painting, which is worth 150,000 to him, and is paying the seller 30,000, right? So the total value that is generated in this example would be 30,000 plus 150,000 minus 30,000. So that adds up to 150,000, right? And you can see that this logic holds true for any mutually profitable deal that you can think of, right? So for example, if the sale was happening for 110,000, right? Then in that case, the seller is going to have 110,000, right, money, and the buyer is going to have the painting, which is worth 150,000, and is going to give minus 110,000, right? So now if you kind of like add up, they can add up to 150,000, right? So we can again kind of like graphically represent this as follows. You've got these two players, 1 and 2. If they cannot make a deal, then the amount that 1 gets is 100,000, 2 gets 0, right? Why 100,000? Because that is the value of the painting to him, right? But if 1 and 2 do make a deal, then the total surplus that is kind of like happening is 150,000. Okay, so that's an example. All right, let's look at an example of a market game with more than 2 players, right? So the previous example looked at the simplest case with one seller, one buyer. But now imagine that there are two sellers and one buyer, right? So that means that we basically have three players, right? So player one and two would be the two sellers, right? And player three would be the buyer. Each of the sellers, imagine, has one good which was acquired at a cost of 100, and the sellers are interested in potentially selling it, right? So when we say that they are interested in potentially selling it, that means that they will sell it if they receive an amount more than 100, right? But would the buyer be interested in paying that amount? Well, that depends on what the reservation price of the buyer is. And here the reservation price of the buyer is 200, which means that this is the maximum that the buyer is willing to pay for the good. Okay. And we also have this condition in this example that the buyer is interested in buying at most one unit of the good, right? So that means that, he will not purchase both the units of the good. The question is, will he purchase one unit or 0 unit? Okay. So clearly the description of the game, the set of agents, set of players is clear, right? This will be the three players. What we need to think about a bit more is to think about how should we go about determining the coalition function, right? So again, we have to specify for each subset of n, what is the value that is generated by the coalition, right? Okay, so n is equal to 1, 2, and 3. 1, 2 are the sellers, and 3 is the buyer. What happens in case no deal happens? So that's pretty clear. In case no deal happens, then V of 1 is 100, right? The seller basically gets to keep the good with him, but does not receive any additional money for the good. So that's 100. Similarly, the V2 is also equal to 100 because if no trade happens, then again, the seller gets to keep the good, which is worth 100 to him. To her, and V3 is equal to 0, where basically if no trade happens, then the buyer does not get the good, and therefore it's equal to 0, right? So notice that here we are just thinking in terms of all transactions that are just related to the good. We are not taking into account all the other different assets or money that the players might have, right? So you could have done that as well, but then kind of like, that does not change anything in terms of our expressions for the solutions that we'll see that we want to later on employ, right? But the key thing is that if you are kind of like want to go around that route, then you need to consistently kind of like keep doing it, right? It's much simpler and cleaner to just focus on our object of study, which is about the transactions that are taking place based on this code, right? So let's focus on that and let's not take into account all these other things that would have been happening, right? Okay. So this is like clear what happens if you have got 1, 2, or 3. But now let's think about more complex cases, right? So suppose we think about 1 and 3. So how should we think about what's the value of V1, 3, right? So first, what does it mean to be a coalition of 1, 3? It means that 1 and 3 have come to some sort of agreement, right? So if 1 and 3 trade, and remember, trade only takes place if it is mutually profitable for both. So what does that mean? That means that in this case, the value of the price that 3 paid to 1 has to be something which is between 100 and 200, right? Why is that the case? Because if the seller 1 is receiving more than 100, then he's making a profit, right? Remember, he had acquired the thing at 100, and that is what was the good worth to him, right? So for example, if P equal to, let's say, 130, then the seller is making a profit of 30 from this trade, right? What about the buyer? Well, the buyer is not going to be willing to pay more than 200. So then that is a upper limit on how high the P can be, right? So what has happened after the deal? So after a deal, one has P amount of money. Again, notice we are not thinking about what other assets the player 1 had apart from this object. So this P amount of money, in the sense that this is the amount of money that he got in exchange for this good. Okay. What about 3? So 3 has the good, right? Which, remember, he estimated to be worth 200, but he has paid some amount for that good, which is this amount P. And so therefore his amount, if you like, payoff from now is like 200 minus P, right? Now, if you add up these two things, right, what is the total value that is generated, right? So then 200 minus P plus P becomes actually 200, right? So that tells us that the worth of this coalition V13 is 200, right? You can put in any value of P between 100 and 200. Once you add up, this will always be P plus 200 minus P, and therefore equal to 200. You can do the similar reasoning for thinking about 2 and 3, right? And you will end up getting again V of 2, 3 will be equal to 200. What about V of 1, comma 2? So this means that only 1 and 2 have come to an agreement, right? So that means that there has been no sale of the good, right? Remember, 3 was the buyer. And so therefore, if there is no sale of the good, then the value is just what the goods are worth to these two different sellers who have not been able to sell. So remember, it was worth 100 to each of them. So therefore, the total value is 200, right? What happens in the case of 1, 2, and 3, right? So this means that this is basically some sale procedure in which all the players took part, right? You can think of various stories, right? So one example of would be the following. So suppose that seller 1 offers to seller 2 an amount P, not to compete, right? And this amount P will be kind of like transferred only if one sells the good. Now, why might the seller 1 want to offer such a deal to seller 2? Well, remember that if competition kind of like happens, then that decreases the bargaining power of sellers, right? Because they are forced to kind of like outbid each other in order to kind of like sell the good. And the only way in which they can outbid each other is by kind of like reducing the price, right? So if they anticipate this and then they decide, it's better off, we might end up getting nothing, and all the surplus might go to the buyer. So why don't we make a side deal, right? So that this is just one story, right? You can think of other stories, but we'll see that all the stories here are going to end up with the same outcome. Okay. So in this story, this is what like seller 1 is kind of like offering to seller 2, right? So now what happens if like all of the agreements kind of like go through, right? So suppose seller 1 sells the good to buyer 3 for Q, right? Let's now think about what is left, right? So for player 1's perspective, then the amount of money that player 1 had as a result of engaging in transaction about this good is Q minus P, right? Why Q minus P? Because Q is the amount of money that the seller 1 received from buyer 3, and then the seller 1 transferred out of this Q an amount P to seller 2, right? So Q minus P is what the uh, seller 1 is getting, right? What about seller 2? So seller 2 gets to keep the good, right? And also gets in addition an amount P from seller 1. So therefore the total that seller 1 has is 100 plus P. And what about buyer 3? So buyer 3 got the good, which is what 200, but is paying a price Q to seller 1. So therefore buyer 3 ends up with 200 minus Q, right? Now, if you add up, you end up seeing that this Q and this Q will be canceling, and this P and this P will be canceling, and it will end up to 300, right? You can think of other stories. So, for example, instead of seller 1 offering to seller 2, you can have seller 2 offering to seller 1. Similar things will happen. What happens if they kind of like just end up like competing against each other without making any side deals? So, you can think in this case that probably the price might be kind of like driven down to 100, right? And then you can end up with like 100. So again, the total surplus is again 300, right? Because the buyer is getting 200 minus 100. One of the sellers has 100 amount of money. The other seller has the good, which is 100, right? So all these stories kind of all would kind of suggest that the value of the coalition where all three are involved is going to be 300, right? Okay. So to summarize, we have now the full description of the coalition function, which again, remember, is mapping each subset of n to a numerical value. So V1, which happens when there is no trade and one is just left on his own, is equal to 100. V2 is again 100 and V3 is equal to 0. V13 is 200, V23 is 200, V12 is also 200. V123 is 300, and V of the empty set is 0 as usual, right? So we can again describe it graphically in the way we have been talking about. So you've got these three nodes, 1, 2, and 3. This 100, 100, and 0 specifies what happens if they are just left on their own. What happens if 1 and 3 reach a deal? That's 200. What happens if only 1 and 2 come to a deal? Then no exchange of goods happen. Then again, the value is 200 out of this goods. And 2 and 3 coming will lead to 200. And finally, all three of them kind of like coming together to make a deal, remember, would lead to a total value of 300 being generated. So these are some examples of how you can kind of like translate any given situation in the language of this cooperative games, especially the mathematical formulation of it. So our later lectures will kind of like focus more on developing, this is the value that is going to the coalition, but what is the value or the money, or how much of the surplus is going to each of the players out of this total value that is going to any particular coalition. So that's coming up in later lectures.